Let's dive into an astonishing discovery that has the potential to rewrite the history of human civilization as we know it.
One of the things I find most striking is the presence of Antarctica on ancient maps, because we didn't discover it until 1820.
Renowned author and explorer Graham Hancock has made a monumental find behind the mysterious ice wall of the South Pole, uncovering evidence of a civilization far more advanced than ours.
Yet it's on maps drawn in the 1500s with great detail, which again were based on much older source maps.
This revelation comes with shocking implications about what we know of our past and challenges the very foundation of our understanding of human history. With Graham Hancock's first-hand accounts, we are taking you on a journey to the edge of the world to explore this incredible civilization.
When I wrote Fingerprints of the Gods in 1995, which is my first book tracing the possibility of a lost civilization, I was very interested in Antarctica, and I was interested in it because of the work of a previous researcher called Charles Hapgood.
Graham Hancock is a British writer who has proposed a fascinating theory about the existence of a lost, advanced civilization that was centered on Antarctica, which was once located farther from the South Pole than today. According to Hancock, this civilization was destroyed by a series of comet impacts around 12,000 years ago, at the end of the last ice age, but some of its survivors managed to spread their knowledge and influence to other parts of the world, such as ancient Egypt and the Americas. What evidence does Hancock present to support this? One of the main sources of evidence is the ancient maps that depict Antarctica with remarkable accuracy, long before it was officially discovered and explored by modern explorers. For example, the Piri Reis map, created by the Ottoman admiral and cartographer Piri Reis, is particularly fascinating because it depicts the coastlines of South America and Africa with astonishing precision, as well as a landmass that closely resembles Antarctica, free of ice. This is a staggering revelation since Antarctica was not officially discovered until 1820, and its coast was not fully mapped until the 20th century. Hapgood proposed that the Piri Reis map was compiled from a collection of even older maps, some of which might have originated from the Library of Alexandria or other ancient repositories of knowledge. What does this imply? It means that seafarers from an ancient, highly advanced civilization had not only explored these regions, but also had the means to document their findings accurately.
Charles Hapgood wrote a number of very important books. One of them is called Maps of the Ancient Sea Kings, which precisely goes into this issue of ancient maps that don't fit our understanding of what the world was, how the world was supposed to be known at that time.
Similarly, the Haji Ahmed map presents another piece of the puzzle. This map shows a detailed depiction of the world, including a landmass where Antarctica should be, but again, without ice. The level of detail and accuracy found in the Haji Ahmed map suggests that it, too, was based on earlier sources, which contained comprehensive geographical knowledge of the Earth. Hapgood suggested that the creators of these maps had developed a sophisticated method of projection, possibly even understanding the concept of spherical trigonometry, to translate their three-dimensional knowledge of the Earth onto a two-dimensional surface accurately. Hapgood's theory further posits that this ancient civilization had not only advanced knowledge of the Earth's geography, but also a deep understanding of astronomy, mathematics, and geodesy. They would have needed to accurately measure the Earth, understand its shape and size, and have a method for projecting this information onto a flat surface. This level of sophistication implies the use of advanced instruments and techniques, perhaps including the astrolabe, quadrants, and detailed star charts, allowing them to navigate the seas with precision unmatched until the modern era. The construction and use of these maps reveal an astonishing level of detail and sophistication. For instance, the accurate portrayal of the Andes mountain range on the Piri Reis map, including river systems that would have been impossible to map without an aerial or high-altitude perspective, suggests that these ancient cartographers had access to information and mapping techniques far beyond what was previously believed. The depiction of Antarctica, free from ice, on these maps also raises intriguing questions about the climate and geography of the Earth in ancient times. It suggests that the map makers had access to geographical data from a period when Antarctica might have been in a much different climatic state, possibly even before the last ice age. The use of sophisticated mathematical techniques for cartographic projection also indicates an advanced understanding of the Earth's curvature and how to represent it on a flat surface. This knowledge is by no means trivial, as it requires a deep understanding of geometry and the ability to apply it practically. The ancient civilization Hapgood describes would have had to master these concepts, along with the ability to measure long distances accurately to create the maps we see today. In addition, the notion that these maps were compiled from sources that predate the known history of exploration opens the door to a fascinating exploration of human capability and achievement. It suggests that ancient mariners explored the globe, charting its continents and oceans with a precision that rivals, and in some cases surpasses, that of later explorers. This ancient global civilization, according to Hapgood, was not isolated but was likely connected through trade, exploration, and the exchange of ideas. Their legacy, preserved in the TERRIFIES and Haji Ahmed maps, offers a tantalizing glimpse into a world that was far more interconnected and advanced than previously thought. Another source of evidence that Hancock uses is the megalithic structures and monuments that are found in various parts of the world, such as the pyramids of Egypt, the stone circles of Stonehenge, the statues of Easter Island, and the temples of Angkor Wat. He posits that these architectural marvels are not isolated phenomena. Instead, they are the remnants of a lost civilization that once thrived in what is now Antarctica. This theory breathes life into the silent stones of our planet's most awe-inspiring monuments, suggesting they were influenced by a sophisticated civilization with advanced knowledge of astronomy, architecture, and spirituality. The main idea behind Hancock's proposition is that the icy continent of Antarctica was not always the frozen wasteland we know today. Before it was encased in ice, it could have been home to a civilization far advanced for its time, possibly possessing wisdom that enabled them to leave an indelible mark on future generations through these megalithic sites. The pyramids of Egypt, with their precise alignment and construction, are seen as a testament to this lost civilization's architectural prowess and understanding of celestial phenomena. Hancock suggests that the knowledge required to build such structures could have originated from this Antarctic civilization, whose people sought to encode their understanding of the cosmos in stone. Similarly, the stone circles of Stonehenge, with their astronomical accuracy, hint at a deep understanding of the movements of the stars and the cycles of the heavens. This knowledge, according to Hancock, might have been a legacy from the seafarers of the lost Antarctic civilization, who navigated the globe and shared their astronomical insights with the inhabitants of ancient Britain. The statues of Easter Island are another puzzle that Hancock attributes to the influence of this enigmatic civilization. These towering figures, with their mysterious origins and purpose, could have been inspired by the artistic and religious practices of a people who, after fleeing a cataclysm in Antarctica, sought to immortalize their heritage in stone. Angkor Wat, with its sophisticated water management system and detailed bas-reliefs depicting celestial themes, is seen as further evidence of this ancient civilization's influence. Hancock says that the architects of Angkor Wat inherited their advanced knowledge from the Antarctic civilization, using it to create a harmonious interaction between heaven and earth, encapsulated in the temple's design. He wondered how the ancient civilizations of Egypt and the Americas, such as the Olmec, the Aztecs, and the Maya, developed such remarkable achievements in mathematics, astronomy, architecture, and agriculture. How did they build monumental structures like the pyramids, the Sphinx, and the temples without the use of modern tools and technology? How did they acquire sophisticated knowledge of the stars, the seasons, and the cycles of nature without the aid of telescopes and calendars? And how did they share such striking similarities and connections, despite being separated by vast oceans and continents? The answer, according to Hancock, is that they inherited their wisdom and skills from an even older and more advanced civilization that existed before the dawn of history. This theory is based on several lines of evidence, such as the alignment of ancient monuments with specific constellations and celestial events, such as the solstices and the equinoxes. The presence of similar myths and legends among different cultures, such as the stories of a great flood, a golden age, and a lost paradise. Hancock suggests that these stories are not mere fantasies or allegories, but memories and records of actual events that happened in the distant past. He believes that these stories preserve the knowledge and the legacy of the lost civilization, and that they contain hints and clues about its location and its fate. The discovery of anomalous artifacts and structures that defy conventional explanations, such as the megalithic site of Göbekli Tepe in Turkey, the underwater ruins of Yonaguni in Japan, and the elongated skulls of Paracas in Peru. Hancock contends that these artifacts and structures are evidence of a high level of technology and craftsmanship that existed before the rise of the known civilizations. He also contends that these artifacts and structures are related to the lost civilization and that they reveal its influence and its presence in different regions of the world. He argues that these cultures, which emerged seemingly out of nowhere and reached high levels of sophistication and complexity, were inspired by the lost civilization of Antarctica, which had a global network of contacts and trade. He also claims that these cultures inherited some of the symbols, myths, and legends of the Antarctic civilization, such as the concept of a sunken continent, a great flood, and a cycle of ages. He also notes that some of these cultures, such as the Maya, had a calendar system that was remarkably similar to the one used by the Antarctic civilization, which was based on the precession of the equinoxes and predicted a major change in the world around the year 2012.
That's probably true. If you go back that far, you would find that the Earth's climate was very different from how it is today. And there's undoubtedly a time, they found fossils on Antarctica, there's undoubtedly a time when Antarctica was lush and green. The question is, was it lush and green during the lifetime of the human species?
Yes, this is where it gets tricky.
And this is where it gets tricky.
As it is, Antarctica is the coldest, driest, and windiest continent on Earth. It is covered by a thick layer of ice that reaches up to 4 kilometers in some places. So it is hard to imagine that this frozen land was once a warm and wet place where forests, ferns, and flowers flourished, as Hancock says. But this is what the fossil evidence tells us. Antarctica used to be a lush and green continent, teeming with life and diversity. How did this dramatic transformation happen? What were the factors that turned Antarctica from a paradise to a polar desert? The key to understanding Antarctica's past climate is to look at its position on the globe. Antarctica was not always at the South Pole. In fact, it was part of a supercontinent called Gondwana, which included South America, Africa, India, Australia, and New Zealand. About 180 million years ago, Gondwana began to break apart, and Antarctica started to drift southward. By 100 million years ago, Antarctica was close to its current location, but it was still connected to Australia and South America by land bridges. At that time, the Earth was much warmer than today due to higher levels of carbon dioxide in the atmosphere. This greenhouse effect created a tropical climate, even at high latitudes. Antarctica was a rainforest, with temperatures averaging 12 degrees C and reaching up to 20 degrees C in the summer. The continent was home to a variety of plants and animals, including conifers, ferns, cycads, palms, magnolias, and orchids. Some of these plants had adaptations to cope with the long periods of darkness during the winter, such as evergreen leaves and thick cuticles. The fauna included dinosaurs, marsupials, crocodiles, turtles, and fish. Fossils of these organisms have been found in Antarctica, preserved in rocks and sediments. However, this lush and green Antarctica did not last forever. About 66 million years ago, a massive asteroid hit the Earth, causing a mass extinction that wiped out most of the dinosaurs and many other species. This event also triggered a global cooling, as dust and debris blocked the sunlight and reduced the greenhouse effect. Antarctica became colder and drier, and the forests began to decline. The land bridges that connected Antarctica to other continents also started to break, as the continents moved further apart. This isolated Antarctica from the rest of the world and prevented the exchange of heat and moisture. The final blow to Antarctica's greenery came about 34 million years ago, when the Antarctic Circumpolar Current, or ACC, was established. The ACC is a powerful ocean current that flows around Antarctica, driven by the winds. The ACC acts as a barrier, preventing the warm waters from the tropics from reaching the continent. This creates a thermal isolation, which lowers the temperature and increases the ice formation. Antarctica became a frozen continent, with ice sheets covering most of the land. Only a few plants and animals survived in the coastal areas and islands, such as mosses, lichens, algae, penguins, seals, and whales.
Our understanding of what the world was, how the world was supposed to be known at that time. And another is called the path of the pole. And he proposed a phenomenon that he called earth crust displacement, whereby from time to time, the entire outer crust of the earth, like the skin of an orange, might shift, leaving the core of the earth.
The Earth crust displacement theory is a fascinating and controversial idea that proposes that the outer layer of the Earth, the lithosphere, can shift over the inner layer, the asthenosphere, causing dramatic changes in the position of the continents and the climate. But the most intriguing thing about this theory is that it could explain the mysterious history of Antarctica, how it moved from a continent that was once much warmer and greener to what it is today. The Earth crust displacement theory was first proposed by Hapgood. As mentioned earlier, Hapgood was inspired by the ancient maps that showed Antarctica free of ice and accurately depicted its coastline. He further said that these maps were based on older sources that dated back to a time when Antarctica was in a different location on the globe, before a cataclysmic event shifted the Earth's crust and moved it to the polar region. Hapgood claimed that this event occurred around 12,000 years ago, at the end of the last ice age, when the massive weight of the glacial ice on the northern continents caused the lithosphere to slip over the asthenosphere, displacing Antarctica by about 30 degrees and rotating the other continents in unison. Hapgood's theory has several implications for the history and geography of Antarctica. First, it suggests that Antarctica was once a temperate and fertile land with abundant flora and fauna, and possibly even human civilization. In fact, some proponents of the theory have even speculated that Antarctica could be the location of the legendary lost continent of Atlantis, which was described by Plato as a prosperous and advanced society that was destroyed by a great flood. Second, it implies that Antarctica underwent a rapid and drastic cooling, as it was exposed to the harsh conditions of the polar zone. This would have caused the formation of the Antarctic ice sheet, which covers about 98% of the continent and reaches a thickness of up to 4 kilometers. The ice sheet would have preserved the remnants of the ancient life and culture that existed on Antarctica before the crustal displacement. Third, it indicates that Antarctica has a significant impact on the global climate and sea level, as the melting or freezing of its ice sheet affects the distribution of water and heat on the planet.
And I've been much more interested recently in the Younger Dryas impact hypothesis and the notion that a cataclysm occurred around 12,800 years ago caused by impacts of comet fragments, and we can go into that.
The Younger Dryas was a period of rapid and severe cooling that occurred about 12,900 years ago, at the end of the last glacial period. It lasted for about 1,500 years and had profound effects on the climate, environment, and human societies of the time. One of the most intriguing and controversial explanations for the cause of the Younger Dryas is the Younger Dryas impact hypothesis, which proposes that a large comet or asteroid fragmented and hit the Earth, triggering a series of catastrophic events that led to the YD. The Younger Dryas impact hypothesis was first proposed in 2007 by a group of scientists who claimed to have found a layer of sediment called the Younger Dryas boundary that contained traces of extraterrestrial material such as nanodiamonds, iridium, and magnetic grains across several sites in North America, Europe, and Asia. They argued that these materials were the result of multiple impacts or airbursts of a large comet or asteroid, about 4 kilometers in diameter, that broke up in the atmosphere and struck the Earth at various locations. They estimated that the total energy released by the impacts was equivalent to more than 10 million Hiroshima bombs. They claim that the resulting shock waves, fires, dust, and debris would have caused widespread devastation and climate change. One of the main effects of the impacts, according to the Younger Dryas impact hypothesis, was the disruption of the Atlantic meridional overturning circulation, which is a system of ocean currents that transports heat from the tropics to the high latitudes of the North Atlantic. The impacts would have melted large amounts of ice from the Laurentide ice sheet, which covered most of Canada and the northern United States, and released a huge volume of fresh water into the ocean. This fresh water would have reduced the salinity and density of the surface water, preventing it from sinking and driving the Atlantic meridional overturning circulation. As a result, the heat transport to the North Atlantic would have been reduced, causing a rapid cooling of the region and the onset of the Younger Dryas. The Younger Dryas impact hypothesis also suggests that the impacts had a significant effect on Antarctica, which was already in a cold and dry state during the last glacial period. The impacts would have increased the amount of dust and aerosols in the atmosphere, blocking some of the incoming solar radiation and creating a global cooling effect. This would have enhanced the growth and expansion of the Antarctic ice sheet, which covers about 98% of the continent. The ice sheet would have become thicker and more extensive, reaching its maximum extent during the Younger Dryas. The impacts would have also altered the precipitation patterns over Antarctica, affecting the accumulation and isotopic composition of the ice. They would have reduced the moisture transport from the tropics to the polar regions, decreasing the amount of snowfall over Antarctica. The impacts would have also changed the source and trajectory of the air masses that reach Antarctica, affecting the temperature and isotopic signature of the precipitation. The isotopic composition of the ice reflects the temperature and origin of the precipitation, and can be used to reconstruct the past climate of Antarctica. The ice core records from Antarctica show that the Younger Dryas was marked by a decrease in the deuterium excess, a parameter that indicates the moisture source and evaporation conditions of the precipitation. This suggests that the precipitation over Antarctica during the Younger Dryas was colder and drier, and originated from higher latitudes than before or after the Younger Dryas. The impacts would have also influenced the ecology and biodiversity of Antarctica, which is dominated by microorganisms such as bacteria, algae, fungi, and lichens. These organisms are adapted to the harsh and variable conditions of Antarctica and play important roles in the biogeochemical cycles of the continent. The impacts would have affected the availability and quality of the resources that these organisms depend on, such as water, nutrients, light, and temperature. The impacts would have reduced the amount and duration of liquid water on the surface and in the soil, limiting the growth and activity of the organisms. The impacts would have also increased the salinity and acidity of the water, altering the chemical and biological properties of the environment. The impacts would have also reduced the amount of light that reaches the surface, affecting the photosynthesis and productivity of the organisms. The impacts would have also changed the temperature regime of Antarctica, creating more extreme and variable conditions that challenge the survival and adaptation of the organisms. Hancock finds the Younger Dryas impact hypothesis fascinating because it attempts to explain one of the most dramatic and mysterious events in Earth's history. It proposes that a cosmic collision triggered a cascade of changes that affected the climate, environment, and life of the planet, especially in the polar regions. It suggests that Antarctica, which is often considered a static and isolated continent, was actually dynamic and connected to the rest of the world, and experienced significant transformations during the Younger Dryas. However, the Younger Dryas impact hypothesis is not widely accepted by the scientific community, and faces many challenges and criticisms from alternative hypotheses and conflicting evidence. But it is still an active and ongoing area of research and deserves further investigation and testing.